guys. Since this Sunday we are free, I have brought some entertaining questions from calculus to entertain you. So let's begin. Here we go. The first question. The first question is asking prove the following identities. So it says the first question says sec x minus cos x is equal to tan x minus sin x. So I had to prove that left hand side is equal to right hand side. So if I take the first equation, sec x minus cos x equal tan x sin x. So I'm going to take the left hand side first. So left hand side is equal to sec x minus cos x, and if I sec x is equal to reciprocal of cos x, so I can write that 1 over cos x, 1 over cos x minus cos x, 1 over cos x minus cos x. So now what I'm going to do is to add, like, to subtract both of them, I have to find a common denominator. So since this common denominator, this denominator is cos x and this one has 1 as a common denominator, what I'm going to do is I have to multiply this cos x by cos x and divide by cos x, so I will get a common denominator. So it's going to be 1 minus, if I multiply cos x by cos x, it's going to be cos square x over cos x. So this is my new one, and what I'm going to do is, since we have cos x right here, the top one is 1 minus cos square x, so I have to bring into this form. So to do that, what I'm going to do is, we have a formula like 1 minus cos x cos square x is equal to sin square x. So instead of 1 minus cos square x, I'm going to put sin square x, sin square x. As you can see, sin square x means sin x multiplied twice, so it's sin x times sin x over cos x. So if you see, it's sin x cos x divide and become tan x, and this is going to be sin x. So tan x sin x. So by doing that, I have made it equal to right hand side. So this is equal to right hand side. Therefore this is the proof. And let's move to the second question. Second question is asking sin x plus y, sin x plus y multiplied by sin x minus y is equal to sin square x minus sin square y. So in this case, I'm going to take the left hand side to prove it's equal to right hand side. First, let's take the left hand side. It's sin x plus y and sin x minus y. So what I'm now what I'm going to do is I can expand this. If we see sin x plus y, it will be expanded as sin x cos y, cos x sin y. So sin x cos y plus cos x sin y, and this is only in the bracket, and if I expand sin x minus y, it will become sin x cos y minus cos y sin x. So it's going to be sin x cos y minus cos x sin y, cos x sin y. So since we have this one here, what I have to do is I have to multiply each of the equation. So for example, if you see this pattern, it's a, like, if you see something like that, it's like if you remember the equation, a minus b times a plus b is a square, a minus b whole square, right? It's a a minus b, a plus b is going to be a square minus b square. It's the same pattern, because sin x cos y same number, sin x cos y same number, cos x sin y, cos x sin y, and it's plus minus. So what I'm going to do is, it's going to be become sin square x I have to just square and subtract. So sine square x cos square y minus cos square x sine square y. So same pattern like a square minus b square pattern. So since we have this one right here, what I can do is let's put the value for sine square x. So sine square x is equal to what? Sine square x remain the same. So sine square x. So what I can do is, since we have to bring everything into sine, instead of cos square y, I'm going to put 1 minus sine square y, because you know cos square is equal to cos square whatever it is equal to 1 minus sine square, right? So instead of cos square y, I'm going to put 1 minus sine square y. So sine square x multiplied by 1 minus sine square y, and I have to get rid of all the cos's here. So here cos square x, it's going to be 1 minus sine square x, sine square x, and sine square y. So now I can multiply this sine square x in the bracket. So it's going to be sine square x minus sine square x sine square y, and minus, and let's multiply this one. So minus, and let's put it in the bracket, sine square y minus sine square x sine square y. So if I expand this one, expand this bracket, it's going to become sine square x minus sine square x sine square y, and this minus multiply both, so it's going to be minus sine square y, and minus minus become plus, plus sine square x sine square y. So if you see this equation, it's here we have negative sine square x sine square y, here we have positive sine square x sine square y. So I can cancel both, positive and negative add and becomes 0. So the thing we have left with is sine square x minus sine square y. So that is the right side. So we have proved left hand side is equal to right hand side. So let's move to the next question. Next question is asking if tan x is equal to 1 over 3. So tan x is equal to 1 over 3, 1 over 3, and they have given another information, sec y is equal to 13 over 12. Sec y is equal to 13 over 12, 13 over 12, and where x and y lie between 5 and 2 pi. So it's between 5 and 2 pi, and evaluate cosec x minus y and cos 2x. So we have to find cosec x minus y and cos 2x. So let's draw the graph first. So if I draw the graph, phi and 2 of phi going to be this between the here, because it's in the bottom, like this is phi, this is 2 phi, so therefore it's going to be here. And we have to remember all student take calculus or all silver teacup. So first quadrant is all positive, second quadrant sine positive, third quadrant tan positive, fourth quadrant cos positive. So since they have given tan x is equal to 1 over 3 positive number, it's definitely going to be in the third quadrant, because they have limited it's from 5 to 2 5, so it's going to be in the third quadrant. So as you know already, tan is opposite over adjacent, so 1 over 3 is 1 is going to be opposite, and this is negative because it's in the negative y axis, and 3 is going to be negative 3. So from this information I can find the hypotenuse. It's going to be 3 square plus 1 square, so it's going to be 9 plus 1 is root 10, and they have given sec y. Sec y is reciprocal of cos y. So if they have given sec y, I can find the cos y. Cos y is going to be reciprocal of sec y. It's going to be 12 over 13. So since this is 12 over 13, and we know cos is positive only when it's in the fourth quadrant or first quadrant, but since they have limited it's from 5 to 2, 5, it's definitely in the fourth quadrant. So I'm going to draw the graph right here. And cos is adjacent over hypotenuse, so we know adjacent is 12 and hypotenuse 13. From this information I can find opposite value by just simply squaring 13 square minus 12 square. So 30 square is going to be 169, 12 square is 144, so 169 minus 144, 25. 25 root is going to be 5. So, and since this y is in the negative y-axis, it's going to be negative 5. So this is our values, and the question is asking what? Uh, Evaluate cosec x minus y. So cosec mean 1 over sine x minus y. So 1 over sine x, 1 over sine x minus y. So first of all I have to find sine x value, and this is our x and this is y. So first of all I have to find sine x value. Sine x is going to be opposite over hypotenuse is negative 1 over root 10, and for this I need sine y and cos y too. So sine y is going to be opposite over hypotenuse, negative 5 over 12, or negative 5 over 13. Negative 5 over 13 is my sine y, and my cos x is going to be equal to adjacent over hypotenuse is negative 3 over root 10, and my cos y is going to be equal to adjacent over hypotenuse 12 over 13. So cos y is equal to 12 over 13. So we have all the information necessary to solve this problem. So let's do that. So if I expand sin x minus y, it's going to be sin x cos y minus sin y cos x. So let's expand this. Sin x cos y minus cos x sin y. So if I put the values here, 1 over sin x is negative 1 over root 10 multiply by cos y 12 over 13 minus cos x is we have found negative 3 over root 10 multiply by sin y we have found already negative 5 over 13. So if we multiply everything together, let's see what we get. 1 over negative 1 times 12 negative 12, and 13 times root 10 is going to be 13 root 10. So negative 12 over uh, 13 root 10, and it's all come under 1. We shouldn't forget that. And let's put a bracket, or let's put a bracket for this, and minus uh, negative 3 times negative 5 is going to be positive 15, and 13 times root 10, 13 root 10. And now we have got this value. Now what I'm going to do is since both have same denominator, I can say this is the common denominator, and it's 15 12 minus 12 minus 15 is going to be minus 27. So 1 over minus 27 over 13 root 10. Since this is 13 root 10 is dividing the minus 27, it's going to flip around and go on top. So it's going to be, the final answer is going to be 13 root 10 over minus 27. So it's the whole equation become minus. So minus 13 root 10 over 27 is the final answer. And we are not done yet. This is one of the question, and they have asked find the cos 2x. So cos 2x is expanded as cos square x minus sin square x. That's the trigonometric basic idea, basic properties, right? So cos 2x can be expanded as cos square x minus sin square x. So cos square x is going to be, we found the cos x here, it's minus 3 over root 10, so I have to square it. Minus 3 over root 10 square minus sin square x is going to be minus 1 over root 10 square. So minus 3 square is going to be 9, root 10 square is going to be 10, minus negative 1 square is going to be 1, and root 10 square is going to be 10. Therefore we will get 8 over 10, which is equal to 4 over 5. So this is my final answer for this question, and that's it. Now I'm moving to the third question. Third question is asking, find all the values x in, and they have given interval 0 to 2, 5 that satisfy the equation 5 cos x minus 2 sin square x equal to 1. Let's do that. So 5 cos x minus 2 sin square x equal to 1. So since we have this look like a quadratic function formula, but since this the one is outside, what we have to do is when we find something like that, we have to equalize it to 0. So we have to bring whatever the value, then only we can factor it or do whatever we want. So first of all, our first step is to make this one equal to 0. So to do that, I have to bring the 1 after the equal to this side, left side. So let's do that. It's going to be 5 cos x minus 2 sin square x minus 1 is equal to 0. So since we have this value 5 cos x minus 2 sin square x minus 1. So if you notice that we have cos and sine, two different things. So we can't do any factoring or anything. So since to separate, I had to try to make all of them in the same format. For example, if you can make it all cos or you can make it all sine, you can do whatever you want. So first of all, if you see sine square x, we can put another thing for sine square x, because according to trigonometric properties, sine square x is equal to 1 minus cos square x. So if I put that, everything become cos. So I can do that. So I'm going to do that. 5 cos x minus 2 times 1 minus cos square x equal to 0. So it's going to be 5 cos x minus 2, and minus going to plus, so it's going to be plus 2 cos square x minus 1 is equal to 0. So I can add minus 2 and minus 1 together, it's going to be minus 3. So 5 cos x plus 2 cos square x minus 3 is equal to 0. Now we have brought it in the brought it to the simple form. So next thing we have to do, in order to factor, next thing we have to do is we have to arrange this thing from highest power to lowest power. So if you see cos square x in the middle, so I have to switch it to the first one. So if I write like that, it's going to be 2 cos square x, 2 cos square x plus 5 cos x minus 3 is equal to 0. Now I am going to try to factor this one. So if you see 2 multiplies the cos square x, so if I multiply the 2 by negative 3 at last, it's going to be negative 6. So the value we have to get is when we multiply, it should give us negative 6, and when we add, it should give positive 5. So if you look at the value, 6 and negative 1 will work out, because if you multiply 6 by negative 1, it's going to be negative 6. If you add 6 and negative 1, it's going to be 5. So I can factor using that. 2 cos square x plus 6 cos x minus cos x minus 3 is equal to 0. Now from this one I can take 2 and cos common, so 2 cos common, 2 cos x common. So if I take 2 cos x common, within the brackets it's going to be cos x plus 3, and in the other one I can take minus 1 common. If I take minus 1, it's going to be within the bracket cos x plus 3 equal to 0. Now I can write two different equations, cos x plus 3 and 2 cos x minus 1 is equal to 0. So I can now separately equalize both of them 0. So first one cos x is equal to minus 3, and second one cos x is equal to 1 over 2. Since if you know the cos, the maximum of cos should be 1 and the minimum should be negative 1, because cos is the range of cos is 1 to negative 1. That's it. If you see any number more than that, it means it does not exist. It is wrong. So in this case, we have got cos x is equal to 9 minus 3, so it doesn't exist. So I have to cancel this one out. And the next one we have got cos x is equal to half. So, and they have mentioned it's this is the interval is 0 to 2 5, so I can take any positive cos x, but cos x is positive in only two quadrants, first and fourth quadrant, so we have to only consider those two quadrants. And when is cos is half? Cos is half at 60 degree. From horizontal it has to be 60 degrees, so if you see in the first quadrant it's directly 60 degree, so it's going to be 5 by 3, and in the third quadrant it's going to be like from the horizontal it should be 60 degree, therefore we have to deduct 60 degree from 360, so it's going to be 300. So 300 multiplied by 5 over 180 is going to be 6 times 3 is going to be 180, and 6 times 5 is going to be 300, so 5 by 3. So these are the two answers for this question. Let's move to the question number 4. So question number 4 is asking, find all the values of x in the interval that satisfy the inequality sin x is greater than cos x. So let's say, first of all, I'm going to treat this as an equal sign. So let's say if sin x is equal to cos x, then what is the value? So if I bring the cos x to this side, it's gonna divide, right? So sin x over cos x equal to 1. So it means tan x is equal to 1. So tan x is 1 only, it's for 45 degree and it's positive. So since they have given the interval, it should be 0 to 2 5, so I have to get the tan positive value. So within this interval, so tan is positive only when it is in the first quadrant or third quadrant. So first quadrant is 45 degree, tan is 1 when it's 45 degree. So 45 degree is written as 5 by 4. So it's going to be 5 by 4, and tan also positive in the third quadrant. So it should be horizontal, from horizontal it should be 45 degree. Therefore 180 plus 45 is going to be 225. 225 multiplied by 5 over 180 is going to be what? Wait a minute. 225 times 5 over 180. So we can say it's 45 times 4 is 180, and 45 times 5 is 225. So 5 over 4 is the answer. And the next question is asking, determine if the following functions are one-to-one, even, or periodic, and determine the intervals of increase or decrease. So the question is saying f of x is equal to x square minus 10x plus 1. So since we have this kind of question, the first thing, if you see some question like this, the first thing we have to do is we have to bring it in the format of a minus b square or a plus b square, if you see that pattern, because this is look like that pattern, right? So since they have given x square minus 10x plus 1, So what I have to do is whatever the x value, like if you see whatever the x value, like if, for example here it's 10, so if just divide it by 2 and square it. So if you divide the 10 by 2, it's going to be 5. So 5 square is 25. So what you have to do is add 25 and subtract 25. So x square minus 10 x plus 25 and minus 25 plus 1. So what I'm going to do is in this I have brought the a minus b square form. So what I now I can just put that format, like x minus 5 square is going to be this value, x minus 5 whole square, and minus 25 plus 1 is going to be minus 24. Now it's easy to draw the graph. It's going to be a parabola opening up because it's x square positive, and it's negative x minus y, so it's moving the right 5 units to the right side, so it's going to be starting from 5, and it's minus 24, so it's minus 24 means 24 units down. So I have to, this is my vertex, so minus 24 and it's going to be 5. So this is my vertex, and the graph is going to be like this. And from this graph I can say everything, but let's see. First they are asking whether it is one to one. So if a graph is one to one, when you draw a horizontal line to this graph, it shouldn't touch more than one line. So in this graph, this is a parabola. If you draw a horizontal line, it's going to touch two sides, two lines, right? So therefore this is not one to one function. And the next question they're asking whether it's even. So to find whether it's even, I have to simply put the x value as negative and see if it's equal to f of x. So let's see. If I put negative x here, negative x square is going to be, okay, that's positive x square, and negative times 10, but 10 times negative x. If I multiply negative 10 by negative x, it will become positive 10x. So therefore it's changing plus 1, so it's changing, f of x is not equal to negative x, therefore it's not a even function. But at the same time, this is not the like if f of x is equal to negative f of x, then it's an odd function. But in this case it's not even equal to that, therefore this is not even or this is not odd. And the next one is asking, is it periodic? Periodic means something repeat again and again. For example, this pattern is like, this is just a parabola, it's not repeating, so this is not a periodic function. And determine the increase and decrease. So if you see, it's from negative infinity to 5, it's decreasing, because if the slope is going from like coming down, it means it's decreasing. So if you see here, it's negative infinity to 5, it's coming down, right? So it's decreasing until that, and from 5 to positive infinity, it's increasing, slope is going up. So that's the answer for this question. Let's do the next question. So next question we're asking, f of x is equal to minus sine 2x, and they have limited it to negative 5 to 5. And so if you see that sine graph, it's going to be something like this, right? It's going to be something like this. So therefore if you draw a horizontal line, it's going to touch more than one line, so therefore it's not a one-to-one function. And to check whether it's even function, you have to put minus x, f of minus x, so it's going to be minus sine 2 minus x, it's not equal to f of x, so therefore it's not an even function. But if you put minus sign, f of minus x, it will become plus sine 2x. So according to the quadratic, like according to the function, if f of x is equal to negative f of x, then it's an odd function. But if, yeah, so uh, if you like f of negative x is equal to negative f of x, it's an odd function. So if you put negative value for x, it become opposite sign of the sine to x, therefore it's an odd function. And next one is, they are asking whether it's periodic. This is periodic, but the problem is they have limited the domain here. So they have said it's between negative 5 to 5, which means it's limited, therefore it's not repeating again and again, therefore it's not periodic. And interval increase and decrease, so to find the interval of increase and decrease, I have to draw the graph. Let's draw the graph. So it's negative sine 2x, so negative sine 2x, let's put it here, negative. So y is equal to negative sine 2x, sine 2x. So this is my graph gonna look like, and let's see. Okay, so here we go. So if I draw a graph for negative sine 2x and the domain is limited to negative 5 to 5, so this is my graph is gonna look like. And if you see this graph, from negative 5 to negative 3 5 by 4, it's decreasing because slope is going down, and negative 3 by 3 5 by 4 to negative 5 by 4, the slope is increasing, and 5 by 4 to negative 5 by 4 to 5 by 4, the slope is going down, therefore this is decreasing. And from 5 by 4 to 3 5 by 4, the slope is going up, therefore increasing. And 3 5 by 4 to 5, the slope is decreasing. So you have to put these values in the bracket like this. So increasing means, for example, increasing, you have to put negative 5, uh, for x negative 3 5 by 4 to comma 5 by 4. I am using this bracket because we don't know exactly at if you see the point x exactly at 5 by 4, negative 5 by 4, we don't know whether it is same because it's turning, right? So we can't say it's equal to that. That's why I'm using this bracket. But some people use square bracket, but this is the mostly right one. And the next question is asking f of x is equal to ln 2x minus 2 minus 5. First question they're asking, is it one-to-one function? So if you draw the graph for ln 2x minus 2 minus 5, let's draw the graph first. So ln 2x minus 2, 2x minus 2 minus 5. So this is my graph is going to look like. And since this case, if you draw a horizontal line, it's going to touch only one point. Therefore, it's a one-to-one function. And to check whether it is an even function, you have to put f of minus x and see ln 2 times minus x, and it changes everything. Therefore, f of x is not equal to f of minus x. Therefore, this is not an even function. And when you put f of minus x, it's not equal to minus f of x. Therefore, it's not an odd function. And if you see the graph, it's not repeating again and again. So this is not a periodic function. And intervals of increase and decrease, they are asking intervals of increase and decrease. Since this case there's only increase, there's no decrease. So if you see it's 0 to positive infinity, it's just going up and up. So it's 0 to positive infinity, it's increasing. That's the only interval. So that's all for today. I hope you guys had fun. See you next time.